Yeah, very good afternoon to all of you.
Good afternoon, sir.
Yeah, good afternoon. Now, in the last week, we looked at functions, then recursive functions and function pointers. So, recursion happens to be one of the most powerful feature of C programming, or that matter, any other programming language if you take. So, let's work out one more problem in recursion, which is slightly more complicated than finding a factorial. So, in my assignment, I gave one problem where you have to uh, perform searching using binary search. All of you are familiar with binary search? Okay,
No,
so
no.
yeah, if not, let's look at one example here. Now, binary search requires the number all should be sorted. So you can search only in a sorted list. Okay. So let's say we are given numbers like this, and we need to find for an element, we call it as key. For example, I want to search whether number 11 is present or not. So the computer has to tell me whether number 11 is present in the list or not. If it is present, it should give me the position of the element in the list. Element 2 is at 0 position, 3 is at 1 position, like that. 2, 3, 4, 5. So 6 should be my answer when I execute binary search. Now, how does it do the binary search? For this, we need to pass the array. Let's say this is stored in array A, and the array bounds are index 0 and n minus 1. So this is your low point of the array, where low is initially 0 and high point is your n minus 1. So I'll be using two variables, low and high. So low points to the first element and high point to the last elements in the list. Okay. Now in binary search, what is done is we find out the midpoint of this array. So the mid is calculated using a simple formula. It's simply low plus high divided by 2. Okay. So now if you observe how many elements are there, 1, 2, 3, 4, 5, 6, 7, 8 elements are there, right? So what is the value of high? Pardon? No, no, no.
N
Value means
minus n.
n minus 1, right? 7. So
7.
low is 0 and high is 7 divided by 2. Since I am doing integer division, I get 3. Okay. So now if you observe, element 2 is at index 0, this is at 1, this is at 2, and this is at 3. Okay. So the mid element is this. Okay. So where is the midpoint of the array? The mid value is 5. Now the key which you are searching is 11. Okay. Now we know that 11 is on the right hand side of mid. So what I have to do is, if key is more than the value of the mid element, I should search in the upper half and ignore completely the lower half because it's not there at all. On the other hand, if the key value where we know that mid value is greater than the key, so I should search in the lower half, not in the upper half. Okay. Now, when I do that, for example, if I'm searching for 11, what I would do in the next iteration is that my low will be mid plus 1. That means I should search in this part of the list. So I will change my low point to this value, that is mid plus 1, and again repeat this. That is, I look for elements in this part of the array. Again I perform low plus high by 2. This time low, we know it is 4, right? The value of low will be mid plus 1. Mid is 3. Mid is 3. And we know that the new low will be 4 and high will remain as it is, which is 8. 7 plus 4 by 2. 11 11 by 2 is how much? 5.5, that is 5.
5.
Yeah, 5. So your index will be, mid will be at 7. Now we see that key value is again more than 7, isn't it? So again I have to change my low position to mid plus 1. So again low will change to your position 11. Okay, so we will be left with a list with only two elements. Now if I do low plus high by 2, can anybody tell me what should be this one? Your low value will be 5 plus 1, that is 6, and high value is again 7 by 2, that is 13 by 2. It is going to be
6.5, 6.
6. Okay, so where is 6 now?
Low.
It is exactly at low.
Low.
Okay, so now you see that your key has matched with the element you are searching, and you have to return that mid position. Okay, so I will first write the program and we shall see how this actually works out.
Sir, just one question here.
Yeah,
So right now we know the key. We know that the key is in the higher end. I mean,
yeah,
after. So
yeah.
what if we don't know where the key is
No, no,
in the
no.
array?
That is what I'm telling you. Given the key, you would always
Okay.
compare with the mid element,
Okay.
right?
Okay.
Suppose it,
But how do we know it is in the low end of the array or like high end of the array?
yeah.
Actually,
Now see what I'm doing. Suppose if it is 2,
Hmm.
I'm comparing with mid. Hmm.
Hmm.
If A of mid is greater than key, it means it is on the left, right?
the passed array is sorted array,
Yeah,
Ashwini.
passed array is sorted
Okay.
array.
Okay.
Yeah.
Okay. 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 Oh, past sorted array. Okay.
Sorted
Got it.
array,
Ah,
yeah.
Ah.
So
So
binary
my
search,
question was, what if it is not
no, no,
sorted?
no. Yeah, on,
Binary search will work only on sorted
yeah,
array.
it works
Okay.
only
This
on
will be
sorted array.
sorted array.
That's why
Yeah.
in the beginning I told you should have elements in the ascending order.
Okay. Got it, sir. Yeah.
Okay,
Thank you.
yeah, yeah. Now, again, if you try to find an element which is not there in the list, for example, 13 or something, it will do exhaustive search, and if it doesn't hit any of the elements, it will return not found. Now, to indicate that it is not found, I am going to return -1 because -1 is not index of any element. But if it is found, I will send the index of the element. Hmm. So this is the logic behind binary search. If I have to implement this using recursion, this is the ideal case because every time I'm dividing the list, I'm getting the same problem with different values of low and high. So what I do is I write int binary search. Okay, and here I'm expecting an array, then low end of the array, high end of the array, and the key that I want to search. So there are four arguments here, 1, 2, 3, 4, okay, including the array. So this is the binary search. The first step here is to find the mid element. So I require a local variable here, mid. Okay. So mid equal to low plus high by 2. So I'm doing an integer division. So truncation will automatically happen because both high and low are of type int. Mid is also int. Okay. Now here I check if array A of mid, if this is greater than the key value, it means the element is on the left hand side, isn't it?
Hmm. Yes, sir.
So
Okay.
here I need to perform binary search on the array A with low as low itself, and high will be mid -1, and you will be sending the key. Else, you know that it is on the right hand side. That is, the key is mid element is smaller than the key. The key is on the right hand side. So this is where you do a recursive binary search. with A as the array. Now low will change to mid plus 1 and high will remain as it is, and then we are passing the key. Okay. Now what happens when A of mid equal to key? That I can write here. If mid equal to key, you are done. You have to return mid because that is where the element is, isn't it? Else, you have to check on either side of the array. So here also you should have a return statement because recursion means it should return after it is done with the lower half or upper half. So there will be a return statement here. This is done. How long should I continue? As I told you, any recursive function that is there, it should have a if condition. Okay, so there should be a if condition here. As long as there is a single element that is possible when low equal to high, you keep doing this. Okay, so once low crosses high, it means you have done an exhaustive search. You are not able to find the element. Then you should say return -1. First, getting into the if block where I find the middle element first. Then I check whether the middle element itself is the key. If so, I return the index of the middle element. Else, I check whether the middle element is greater than the key. Means whether the element is on the left or on the right. If on the left, I will make low as it is and make the high point of the array as mid -1. Because low mid -1 forms the lower half, and on the else part, mid plus 1 high forms the upper half. Okay, so this is the logic behind the binary search. So here I would write the prototype. First part is an array, second is low, third is high, this is key. So just the data types you have to mention. You can say binary search. I need to declare the array. So I will take a array which is initialized right here. So 2, 3, 5, 6, 9. So it should be ascending order 22, 29 like that. So number of elements are 1, 2, 3. I left one comma here. 1, 2, 3, 4, 5, 6, 7, 8. So n is equal to 8. Okay. Now I need to call binary search here and store the result in a variable. So I can take one more variable result, which will store the index of the variable. If found otherwise, it will store -1. So I call binary search. So when you call binary search, I need to pass the array. Then the low point of the array, we know it is 0. The high point of the array initially is n-1. And the key that you are trying to search, possibly you can get it from the keyboard. You can take one more variable here, key. You can give binary search and then say enter value of key. And here you put a scanf, %d, ampersand key. And this key I need to pass to binary search. And if result greater than 0, it means element is found. So you can say printf element found at position d, comma, else printf /n element not found. Okay, so we initialize the array with some elements and we noted the size. Then we are asking for the key to search, and if it is found, we are saying it is found at appropriate position, and then not found, we are reporting accordingly. Okay, so hope everything is fine here. So let's try to find out 22 if it is there or not. So we know it is in the list. I left a semicolon here. Okay, now it is asking for element 22. So there are 8 elements. The index of 22 is what? 29 is index 7. So 22 should be index 6. So it is saying element found at position 6. Correct? Similarly, if I try to search for number 3, it should be index 1, position 1. And now if I try to enter a number which is not there, for example, 55, element not found. Okay. So this is doing the required task correctly. And as you can see, the recursive function is very easy to implement. You can do this iteratively also, but you need to follow all the steps correctly and try to implement using a while loop there. Is this logic clear? Would you like to implement and see?
Yes, sir.
I told you some time back that functions can be written outside this main file. So you can create one more file, let us say disp.c, where I simply write one display function, stdio.h, then void disp. It will simply print I am in display function. Okay, so this function I want to call here in main. So in main, you can say I am in main. And after this, if I say disp. Now disp, I know it is not in this file. So I should tell the compiler where is this. So I can say extern disp. Okay, and disp we know it is not returning anything. So I should write the function prototype like this. Now if I run the program, I should get I am in main, I am in display function. It means if you don't mention anything, by default it is external. So even without that external keyword, it works. Okay. Now, if in this IDE, you are just saying run and everything is happening for you, but exactly what is happening behind the scene should be understood if you are getting deeper into, how programs are actually compiled. So let us first see the whole compilation process. So are you able to see my screen here?
Yes.
So I showed you that there are two programs, right? So we have this main.c and disp.c. So these are called as source files. And when you actually do run program, there are 4 steps which are happening here. The first thing that happens is, as I told you, every program has a preprocessor section, that is header section, that is hash include, then hash define, all those things will come under preprocessor section. Now this preprocessor section is processed first. So how is that actually done? So there is a GCC compiler, GNU Sync compiler. So this stands for GNU. Okay, G stands for GNU and C for C compiler. So there is this GNU is a recursive kind of a name. It is GNU but not Unix. This is how it is. G here and N here and U here. So it is GNU but not Unix. That is how GNU, that G appears here. Now to first thing is you give a main.c to a GCC compiler with a switch -v. So these are called as switches. So depending on the switch, the GCC compiler does different things. So what it does is it will take main.c and gives you main.i, which is a file which contains all the preprocessor steps included in your compiled program. We know hash include stdio.h is there. That stdio.h itself is a very big file containing lot of hash defined statements and all the function prototypes of the library function that you may make use of, which are there in stdio.h. So all that will be included in the output file. So here you have to use the source file, then give a -o option, which will tell what is the output file like. So output file is named as main.i. So you can think of this .i file as some intermediate file. Even before actual compilation starts, you can think of this main.i as intermediate file, which contains all the preprocessor statements included in the file main.i. Likewise, you have to do the compilation of the disk.c also, gcc minus e disk.c minus o disk.i. Okay, so we'll see what is contained in disk.i and this main.i. I will show you at the command prompt. So after pre-processing step, you will get these two files. The next step is convert this entire file into assembly program. Now, the compiler doesn't convert the program directly into machine instructions. Okay, first it will convert that into assembly program. So some of you have done from computer science or electronics, you know that there is an assembly language which uses mnemonics to represent some of the commands. For example, add a comma b. So this is the assembly instruction, or add comma b like this, and then call some function fun. So these are all assembly instructions which the assembler understands, and these are finally converted into machine codes. So you can take the .in file and give it to again GCC compiler, but this time use -h switch. This -h will s will convert the main.i into main.s. That is all statements containing assembly instructions. Now assembly instructions themselves, they cannot be executed directly on the machine. You have to convert that into machine code. So the next step in this compilation process is generating object code. So object code is exactly the machine instructions. So all these assembly statements are converted into machine code. For example, add a comma b can be a machine code like 8e, and this call some function maybe cd and some number, some address here, let's say cd 4000, something like that. So the compiler knows how exactly to take each assembly instruction and convert into machine code like this. So to compile that into machine code, we have to use the switch -c now. -c will take the assembly program and convert it into object files. So these .o files are called as object files. These object files contain machine instruction, but still not ready to be executed. They cannot be directly executed because certain library functions which are used, they must be linked. So the object files are created and all the files must be linked along with the library function. So since you are using main disk.s in main.s, these two files must be linked together. So the linking happens in the last step, where you just say GCC without any switch and specify the object file main.o disk.o and generate the final executable like this. Now you are not specifying any object file of library functions. It is automatically linked because in the pre-processing step, it knows exactly which library functions you have made use, and it knows which object files of the library functions to link. So the final executable will be created and you can run this. Okay. So In the IDE, you are just clicking on the run button, but in the background, all of this is happening. Okay. So let us see the demonstration of this. I will show you how each step can be carried out in the command prompt. For that, let us take our program from here itself. So what I do is I simply copy this and put that in a text file and save it. I will take a folder B. Here I can create a folder. Let us say compilation demo or comp demo, something like that. So this is what is our main.c. Okay, so I saved this in that comp demo. Similarly, I can take this second file, your disk.c, copy this into your notepad, a new file here, and save this again in the same folder as disk.c. Okay, now I move to my command prompt, cd comp demo. Now if I see, there are two files here, our main.c and disk.c, right? Now if I type main.c, I will see that source file. Similarly, if I type disk.c, I get the second file. Okay. Now there are only two files. If I show dir, there are only two files. Now I apply the GCC compiler switch -e, okay, on main.c and get the main.i. Okay, and if I see that file, it's a big file, 21,000 bytes. That is because that hash include str.h is a big file which is included. Okay, now if I type main.i, you will see a lot of lines here. So this is what that preprocessor has done. It has included everything which is there in your header file. Okay, so many str.h and other things are all there in this. It's a big file. Okay, of course it will be curtailed later in our steps. Similarly, I have to do compilation of your disk.c into disk.i. So now you have two .i files. Okay. Now the next step is where to generate the assembly program out of this. So gcc -s main.i output main.s. Similarly, gcc disk.i -o disk.s. So now we have, yes, you will see assembly program here. And L, subtract L, call, move L, like this. So these are all assembly instructions. Okay. So this is what is main.s. Similarly, you can see disk.s. So that will also be similar. Okay. So there are two assembly files now. Next step is generate the object file, -c option. Then we have to say main.s and output file will be main.o. Okay. Then similarly, I can give disk.s and disk.o. I have the object file. Okay. Now if you type this main.o or disk.o, you will see some garbage here. This is all machine instructions, right? Which only the machine can understand. So it looks more like Chinese language here. You don't make out anything, but when you link them together, it will generate an executable file. So last step is gcc, then without any options, main.o, then your disk.o. Output file should be the final executable. And if I say dir, you see that final executable.exe has come. Now if I say final executable.exe, you will see I am main, I am in display function. So the program is running here. Okay. So you as a programmer of C should know all the inner steps which are carried out without your knowledge, and how exactly the compilation happens in steps behind the scenes and final executable is generated. Is that some useful information for you?
Yes, sir.
Okay.
Yes.
This is only for just information's sake. You will not be doing this compilation manually anytime, but you should know what exactly is happening with the functions which are called from outside the file. Normally, when you work on big projects, you will be using hundreds of files. So all those files have to be compiled separately into object file and linked together to generate the final executable. All right. So that is the whole compilation process. Now,
Yes.
the other day we looked at function pointers, and still some of you may not be very comfortable with them. So let us see one example where we and we'll see a more complex application of function pointer where a function can return a pointer to a function. That's a more complex scenario. We shall see that also. But before that, let me show you how to declare a function pointer and do some task. For example, you want to add two numbers and you want to call this through a function. I don't know how many of you have experimented with function pointers, but I'm just demonstrating one more here. We know that we simply have to return a plus b here, not a big task to perform, but how can I invoke this with function pointer? We know the prototype of this is just this. Now, if I want to declare a pointer to this function, if any of you remember, can you let me know how I can declare a pointer to this function? What is the syntax?
Star F.
Star,
Int star FPAPR.
Int
star,
int star f.
star fp.
TR.
Yeah.
TR.
Okay, whatever.
That
Star fp, right?
int star FPKR, sir.
Yeah.
Int
Any,
Yeah, int star
yeah,
FPTR.
int should come here when within the bracket ftr should come.
yes.
And you should indicate
Int
what are the argument
Int
it is
command.
receiving.
int.
Int comma int, right? So this pointer fptr is now capable of pointing to any function which returns some integer value and takes two arguments. Okay. So I can say fptr equal
Equal to ampersand add.
or just add should be okay, because I told you function name itself is a address.
Address. Yes.
Yeah.
Okay, so you need not have to, and you just have to call the function just like that. Okay, and it will return some value. So I need to declare some result here. And when you call the function, you must pass the argument, let's say 6 comma 7, and hold the result in res, and you can print this result equal to percentage d comma result.
Yes.
Yeah, will it work?
Right.
Let's try. As you can see, we have 13 as the answer. Okay. Now, yeah. Any doubts here?
No.
Okay. Now, suppose you had one more function, subtract int a comma int b, or you can say something little different, int xy, and return x minus y. Can I use the same pointer to point to this also?
Yes.
It should be
Yes.
possible, right? So after I'm done with addition, I can use the same pointer fptr to point to this function sub. Okay, of course the sub function we have to declare here, int sub comma int. So I don't have to take another pointer, function pointer. You just use the same because the signature of the function is same. So sub like this, and if I say result equal to fptr 7 comma 8, I should get answer as -1. Result equal to, you can put a slash in here so that it comes on the next line. Percentage d comma result. Yeah. So hopefully everything is okay, and you can see result is -1. Hmm? So it doesn't matter what function you are calling, the function signature should match. Yesterday we saw GCD also, which takes two arguments, right? A comma B, isn't it? So what you implement inside doesn't matter. I can assign FPTR to GCD also now. Is that right?
Yes.
Yes.
FPTR, then you can say 24 comma 16 like this. So I should of course implement GCD correctly here.
But
Yes.
first you have to
Yes.
assign it, sir.
Huh?
First you have to GCD, you have to FPTR is equal to GCD, you have to
Ah,
give
yeah,
it.
yeah, sure, sure. You have to say FPTR equal to GCD.
GCD.
Okay. So we should be very comfortable using function pointers like this. Hmm? Okay. Yeah. Now, if I have to declare an array of function pointers, that is also possible. Now I am declaring single pointer here. Suppose if I write like this. Now there are actually uh, three, two pointers here, FPTR 0 and FPTR 1. Okay. So what I can do is this FPTR 0 I can assign to add. Okay. And when I call this, it should be like this. It means one function pointer is pointing to add, and this is pointing to 1. So using the index just like an array, I can use pointer like that. And if you want
Yes.
one more, you can have this FPTR2 assigned to. Since it starts with index 0, it will go up to 2. Here, this will point to GCD and it will call GCD like that. Hmm? Yeah.
Sir, what difference does it make in calling this way and the other way?
Yeah, now it doesn't make any difference. Should still work. Only thing is, suppose you want to put that in a loop and
Okay.
call different function while the loop is moving, you are done. So using an array of functions, see this is working still. Now I am using index 0, 1, 2, 3. So what I can do is I can use a for loop and run all these functions. I don't have to call them separately like this. Okay.
Okay.
So
Okay.
in operating system, what happened? There is a device drivers, a concept called device driver, where the device has to perform many things. You have to initialize the printer. You have to move the printer head to the left. Then you should check whether there is a paper or not. Then check whether there is ink or not. If everything is okay, you should start printing the document. So this thing require many functions to be run one after the other. So you can put all those functions in an array and run a loop. If there is
Okay.
any error in one of the function, you can exit that loop. Okay.
Okay.
So this area of pointers is also a very important concept you must remember. Is that okay? All right. Okay. Now the next more complicated thing is, yeah.
Can we just execute this, sir? Because it is a, I mean,
Pardon?
last class what we can we execute this?
Yeah.
Because last class what we learned that is totally a bit different.
Yeah. Yeah. See, I executed and you're getting the output 13 and -1.
Okay.
Same output you'll get. Now, you want to try this out, huh?
Yes, yes.
Oh, okay, okay, okay. Just give a try. Okay. So as you can see, we can run all the three functions by putting them in a loop. So when I equal to 0, the first function pointer will execute addition. When I equal to 1, subtraction will happen because it is FPTR1. And when I equal to 2, it's going to be GCD because FPTR2 is pointing to GCD. We will get the result in the output window like this. So if I show you the output, uh, so GCD is 8, result 69, 37 and 1. This is the three result outputs what you see here. They correspond to executing the function pointers in a loop. Where here,
Yeah, yeah, last one.
yeah, because
No.
53 and 16, the GCD is 1, no?
Okay, okay.
Because 53 is a prime number and 16 is a even number. So any prime number, one of them will always get 1. Okay. Because here GCD, when you are executing, you are passing 24 and 16. So you are getting 8 there.
Okay,
Okay.
okay, okay.
And here the number are 53 and 16. That is why it
Okay.
is 1. Hmm?
So there are two statements which got executed. That is why I got confused.
Okay.
Yeah.
So now it's clear, right?
Yeah.
Okay, good. There is one more concept. Can function return a function pointer? Okay, so this is slightly difficult to understand. Can function returning a function pointer? We know that functions can take function pointers. Yesterday we saw that compute was taking square it and cube it. That part we have seen. Functions can take function pointers as arguments, but can function return a function pointer? That is what we shall see today. Okay. So how can I declare a function as a function which is returning a function pointer? So here is an example. So all of you are able to see my screen?
Yes, sir.
Okay. Now just observe carefully that I have a function void show and it is accepting an integer x. Okay. What it is doing, it is simply printing the value of x. Okay. Now the function get me should return the pointer to this function. That means within the body of get me, there should be return show. Okay. So the return value of the function itself is a pointer function or function to a pointer. Okay. So how do I declare that? First thing is we know that show is returning void, right? So I'll put a void here. Hmm? Then star name of the function that you are implementing. Okay.
I will give function
You can
pointer.
give any name, star get me or star fun or whatever. Now this get me function is accepting a string. So char star str is there. But this get me function is a function returning a function pointer. So the function show is accepting an integer value. So that will come at the last part of this function declaration here. So this is a slightly complicated function declaration which you might have never seen before. We need to understand what are we are doing here. The first part void is the return type of this show function, and the last part of this is the argument of the show function. Got it? And this get me itself is accepting a string pointer. Hmm? Yeah. So this is how we declare a function which is returning a function pointer.
Follow.
All right. Now in the main, how will I assign this or how will I invoke this function? The first thing is we know show function has a return type void star fp, then it is accepting an enter. So this is a your normal declaration of a function pointer. So it can point to show me or show function. Correct, no? This FP can point to show function, right? Yeah. Now, mute ಮಾಡಬೇಕು. Okay, now uh, this FP can now point to get me. So get me is accepting a string variable here. Okay. So there I am pointing, hey, this is Sunil here. Okay. So FP points to this one. And FP, this get me will return a pointer to show me function. Okay. So get me you are calling here. You just are normally calling get me. Get me is returning a pointer of this type. Correct. And that is why I should declare FP as void star FP int. Okay. So what actually is happening is FP is getting pointed to the show function, and once you come out of this get me assignment to FP should be invoked with a integer argument because this show function is taking int x. Okay, now if I run the program, you will see that get me is displaying whatever string it is taking, and FP when you call with value 5, it is printing 5. So 5 is x value, the show me is called, and before that you will see there is a string, hey, this is Sunil here. Okay, and before that within the printf you have I am get me, both are there. If you don't want this part, you can only print what is coming through the function. So now if I run this, you will see only two strings getting displayed. One is the string which are passing from the main, and the second one is the show function which is executing the x value being 5. Okay, so this is a slightly complicated concept to understand because so you need to understand how the whole thing is declared. And get me function, see how the declaration is done. It is returning a function pointer which is a function with return void and an argument int, and get me itself is taking a string. So that is how the declaration of get me will be done. So just make note of this and try to do this yourself. And if you find it difficult to implement, we shall see once again in our next session. All right. Any doubts here?
So this show function is returning void, then
Hmm.
I'm still not able to follow. Like,
Yeah, see, I want this get me function to return a pointer to this function. Okay, get me will return a pointer to this function, that is show function.
Instead of this show, instead of returning show, can you just have show and then
Yeah,
return something like
see,
that? Or
this you can say show here, absolutely no
yes.
problem. But you know, there might be a requirement where a function has to return a
Ah,
pointer to another function depending on what you are passing. Hmm.
okay.
In a more complex scenario where this may be a requirement, not that we are
Hmm.
doing this to make
No,
things very complicated, but this could be one
no,
of the requirements.
no. My ask is if we don't return anything, will not return. Meaning by default, will it return something or how it is? Because see,
No, 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 no.
I,
See, this you have to return something, no, because the return type is void, pointer, and int. That is
mm,
a function to a pointer. Sorry, pointer to a function. So return show has to be there. It can be any other function also which is of similar type. For example, if I have void disp which is taking an integer value and doing something here, whatever it is, then you can say disp also. Okay, any function which is of this nature that it has return type is void and it is taking one integer argument, then this function get me can return that.
okay.
Okay.
Hmm. And instead of this, okay, I do have one requirement. If see, this is the function name. Okay, instead of this here in 29 line, instead of return this, okay, can I pass the function name itself from the function name itself as a particular parameter, so that instead of
No,
this,
if you know that here
mm,
function name only, you can call it. No,
mhm.
of
No,
course you can.
I ask is like, okay, I want to call the this,
Hmm,
okay, via the get me.
hmm,
So get me is kind of like doing some particular setup part,
hmm,
okay,
hmm,
and this is doing something display. After setting up that part, I am using the display.
hmm.
So in my case, what I want is, in some cases I want to do display, and in some cases I want to do display a show.
Okay,
Okay,
okay.
in some cases I want to call a show. So in that case, can I pass the function name itself as a parameter to this get me function?
Yeah,
That
you
is what
can. You can. Then this argument has to be again a function pointer to a function.
okay,
I have told
okay,
you know how you do like star fp. Then
okay,
it should be returning void. Then it
okay,
has to be int like this.
oh,
Okay, so
okay,
then you can pass disp once and show.
uh, okay,
Okay, so then again
okay,
everything will change. Get me declaration here will change.
okay.
Okay,
Yeah, instead of cash tag, you need
yeah,
to again
yeah. And
give
here,
the
here is
component.
what you will be passing your add or your display
Mm,
or show.
okay,
Got it?
okay. Yeah,
That
yeah,
is
yeah.
also
Instead
doable.
of X,
That is also
okay.
doable. You just try that out.
Mm-hmm.
If it works for you, that's great. Hmm?
Okay.
Okay.
Yeah.
All right. So to summarize, we looked at recursion in a more detailed way where we implemented binary search. We shall take up more of these like in merge sort and quick sort, how the binary this recursive calls are made. Then we went on to see how a multi-file compilation actually happens behind the scene. So how the intermediate code is generated, how the assembly code is generated, and then the object code is generated, and then all are linked together to generate the final executable. And we also saw how to use uh, function pointers. And again, you can implement a function which returns pointer to another function. So that is a next level of pointers to functions. Okay. So just try few of these things, and anything that is given in the assignment, if you try, you will get to certain level. All right. Okay. Shall we close for today? Convenient because you will get all the videos in a sequence. Hmm? All right.
All earlier
Yeah.
sessions when
Earlier
we
sessions are also there. When you log in, go to C programming there. You will get a drop down list. We will expand there, and you will see one of the entry there is videos. So click on that. It should come up. Hmm?